Hello, everybody. I'm really happy to follow guys that actually almost line up with what I do on a daily basis here. So today, I'm going to talk about what my job is as opposed to the academic side of what I do. And most of you, I think, in this room probably know me more through my academic side in the Climate Science Center and studying climate policy in the political science department. But my day job is that I'm one of the energy managers for Texas Tech, and I work in the operations division. And so every day I sort of have the task of getting our house, our communal house, together. And primarily we do that through sustainability issues and solutions. So first let's look at our house. Our house is really beautiful, I think, but it's also massive, right? 190 buildings and almost 9 million square feet. It's a lot to manage for our small office. Our office has 3 full-time staff, of which I am just one. So when we think about this house and its impacts, I think what I've been asked to talk about today, and probably what most people want to curtail, is this carbon emission aspect of it. And we really want to reduce our emissions associated with the university. So I put together this graphic that comes out of our office. Our office is exclusively energy, so we're talking our natural gas use and electricity, and of course we heat and cool the campus with chilled water and steam that are made from those other fuel types. So really we're talking electricity and natural gas here. And as you can see, it sort of fluxes over time, but for me, I thought about coming and putting more relatable graphics: how many trees, how many SUVs, how many dead polar bears this carbon should be associated with. But that's not really how we think about it. Of course, in the Office of Sustainability, we think about how many dollars is this, and how many kilowatt hours, how many MCFs can we reduce. So we think about it in its energy terms, and that's how I'm going to talk. But for all of the presentation, you should know that energy and carbon are completely related as we move forward here. So inside our office, we're constantly looking at ways to reduce the energy consumption of the campus. So in that question, we wonder, well, how is the campus driven in terms of its energy consumption? So is it by the users of that energy? Is it by the enrollment, or is it by how dense their usage is in something more like credit hours? Is it driven by weather and seasonality, or is it really the number of buildings and the size of those buildings? So all of you can think about what you think the answer is, and I'm just going to whip through a couple of things. See, if we were to use enrollment, it's a moving target, because as you all know, Texas Tech is expanding, and according to my data, we're expanding at about 600 students per year. So rapid expansion there. Credit hours similarly expanding. The weather factor, though, this is a sum of our heating and cooling degree days. There might be some industry-specific terms there, but it's basically level, which is what you would expect over such a short-term analysis like this. Slightly down in terms of what we've needed in terms of heating and cooling. I don't necessarily know why that is, and it's too slight for us to even care about, actually. So what we do often look at is the weather sensitivity of campus. So this is your 12-month monthly average, and it goes back about 5 or 6 years. And you see in here the, if I have a mouse on here, yeah. So you see this peak is the wintertime heating demand. This is all of our steam usage going up. And then this little peak is summer air conditioning, and summer air conditioning is coming down here. And of course, campus isn't quite as occupied in the summertime as it is in the wintertime, so you see that effect is not quite as pronounced. The other thing you should also notice in this is that it's really not that seasonally dependent in terms of our energy use. The seasonal factor is about 15% of total energy consumption, while what we call the baseload energy use is about 85%. So we're really not being driven by the weather. So sorry if that was the one that you guys had picked. The one that I think is the biggest driver is actually just the number and square footage of buildings. So we are growing at a rate, according to this, of about 70,000 conditioned square feet per year on campus. It's an enormous growth. So it's a tough moving target for us to hit. So in our office, really, we know that all of those things obviously contribute to energy consumption. But I think if you were leaning towards the number of buildings, then give yourself a pat on the back, because that's what we think is the most effective. But to protect ourselves from having to hit a moving target for our own evaluations, we have to then divide by conditioned square foot to find that stable evaluation criteria. So this is kind of the formula that most university campuses use. You combine all of your energy inputs into one big numerator, and then you divide by the size of your campus and conditioned square foot in the denominator. So it's fairly simple. Our number is 153. At least that's the number we're publishing right now. Don't really take that outside of the room. It's meant for internal comparison year to year, not necessarily external comparison, because University of Texas publishes a 200, Texas A&M publishes something like 180, and that's not to say that our 150 is better than theirs. It is, but we don't say that. But it's just that this is how we compare to ourselves, not necessarily to others. So how have we done in that stabilized metric? This is the same time period, so what we call the millennial graph. This is how we've done over time. And you can see we've pretty well established a downward trend in our energy use index. So I'm just going to whip through some of the things that we do to make it happen. Originally, this will work in your house too, by the way. We put the building on a schedule. Originally, back in 2000, 2001, campus was running 24/7, all buildings on all the time. As soon as we put in schedules, we see that energy use index come down by a large margin. We started doing lighting upgrades. This is your low-hanging fruit. We, instead of running the air handlers at full speed all the time, we put variable frequency drives in so that they can gear down a little bit and run slower and save some energy. We very specifically have started looking at how we manage our air handlers during cold weather. And of course, we gain efficiency benefits from our utility department, which is the central heating and cooling plant. And the waterside econometer is one of many examples that they've done to really make the production of chilled water and steam cheaper or more efficient. We, of course, recommission buildings. Texas Tech has a lot of aging buildings. A recommissioning process is when you go through and make those aging buildings function like they're new or as close to new as you can get them. And now we're starting to implement lighting control, so you're starting to get into your more high-tech stuff, not quite as high-tech as Brian's stuff. But we're approaching the technologies to do occupancy sensors. Some of them can be fairly high-tech. And getting into what our current project is rolling out of smart meters into all buildings so that we can get real-time 15-minute data and create building dashboards so we know that every building's doing with all of its fuel types at a moment's notice. So we're starting to do some fairly high-tech things. And we think through continued processes that black line on the bottom, that 117, that's our goal. It's our 10-year goal that hopefully we can achieve an energy use index of about 117. So you see we've come down from just over 200. We've got a long way to go yet. So what does that do? Well, that saves us money. It saves the university a lot of money, in fact. And since the creation of the Energy Management Department in 2006, that cumulative savings is about $10 million. So with just what we have 3 staff now, but of course in 2006 they only had 1. With very small staff, we're able to profit quite a bit for the university. And of course, all that goes back into research and other things. So that's a big deal, but I'm guessing most people haven't heard of it. And I think the reason that you haven't heard of it is because I sit in this little silo. It's very rare that someone like me sort of spans the academic departments with operations department, right? I'm staff. And I am in energy management, and even within staff, energy management doesn't get to talk to new construction all that much. So the people who design LEED buildings, well, they don't talk about the people who manage those LEED buildings afterwards. And it's a big problem. I mean, for this audience, many of you may, or some of you may sit in the student body, and I am fortunate enough to have worked some in there, creating the Green Initiatives Committee in student government and working with Engineers for a Sustainable World to look at some renewable energy projects on campus. But even in the student body, you may be interested in some sustainability projects or energy reduction projects, but you don't get out of that silo. I think the majority of the room probably fits into this. Faculty. For faculty, we hope to create a communication initiative between energy management specifically that we're going to call energy stewards. So people who might run a building or look at energy use in a building specifically and then communicate to building occupants of things that we are trying to accomplish to save energy. But we don't have that. We may roll that out in the next year or so. And then finally, you may be in administration and concerned about sustainability or the cost and impact on the planet of the university, but there's not necessarily a way to communicate outside of your silo. So I think we have all these individual concerned stakeholders. And what I'm trying to produce or create on this campus is this idea of a council that spans all of these silos and brings interested representatives into a committee to communicate about sustainability issues and then go back and report to your stakeholder group. And it's very difficult to try and get that thing off the ground, but we're piloting it, and we've got more and more people interested every year. So what we really need is for those of you out there to be interested and to communicate and to come communicate with us in a way that sets a unified direction for the campus. So what I'm envisioning is not a lot of work, but a way to get everyone on the same page. So once or twice a year, we come together, we talk about what it is we're doing, where we hope to go, and have that unified message that we can disseminate to everyone outside of campus, on campus, and in all of these different groups. So that's what I'm kind of asking for from the administration and for my own operations division and from all of you. And with that, I will take any questions about our methodology, accomplishments, and communication ideas. Yes?
On the Energies and Index page, you showed where you want us to be. What sort of projects do you have in mind to get us there? Solar panels?
Yeah, I didn't talk a lot about our energy portfolio because we don't have a lot of freedom to deal with our energy portfolio. Like the wind farms that you see very nearby, we can't have access to them. We are subject to LP&L's energy portfolio, but we could do our own power, as you mentioned. It's just that if you're really concerned about carbon numbers, it's not the most cost-effective way to get there. And if you're concerned about saving cost, it's not the most effective. So renewable energy is somewhat far down on our list, and I think is a great example of why we need the Sustainability Council, because every semester, multiple times in the semester, we're asked, why don't we have solar? Why don't we have wind? So we're constantly defending this position. Well, because it's not cost effective and it's not carbon effective yet for us. And what we'd really like is for everyone to be on the same page, and instead of spinning their wheels and asking the same questions over and over again, to sort of know where we are and then to move forward incrementally in a positive direction.
So what are your efficiency plans then, which is I think the question, what efficiency?
And the efficiency plans are pretty much the same things that we've named. We have 200 buildings. It's difficult to recommission them all at one time. So we've got buildings on a recommissioning schedule. The smart meters allows us to specifically target problem buildings, whereas right now we don't have even meters on every building. So I look at what we call E&G, so education in general use. I just look at a big pool of buildings and I say, oh, steam's up. Well, what should we do? And so we have very limited granularity of what we can do to find a solution. Maybe someone should walk the steam tunnels and find a leak. Well, they're 7.5 miles, so pack a lunch. But if we had some meter there that told us all of a sudden there's been a big change in this building, then we would be on top of it within a matter of days and able to fix it. And it would be a huge improvement. So I think smart meters is going to open up a massive possibility for us. The second big thing we're doing is CO2 checking and then ventilation of buildings based on their CO2. So it's called demand control ventilation. That will be probably as effective as it was to set the campus on a schedule. Yes.
So two-tier, I did have a curiosity about 2006 and 2010 on your index, and I understand that you have constrained information resources, so I was just wanting to know if you had an idea of why you saw, was there an increase in construction, or why do you see those peaks there? And I have a solution for you.
You're talking about the energy use index graph in 2006?
Yes. So
how it goes back up?
Yeah, I'm seeing kind of an upward trend, 2005, 2006, then it goes back down, and then also 2010. And I'm wondering if you know why, if suddenly you incorporated more buildings in your data, or...
Well, remember that buildings are removed because we're dividing by the square footage.
Okay.
So it can't be buildings, but we know that in 2010 we had freeze damage in previous years, and it was very expensive. So in a reactive response, the university said, if it's below freezing, or maybe even if it's below 40, we're just going to go back to 24/7. Turn everything on all the time. because we don't want coils freezing up. We don't want to have to replace it, because then you have people without heat, and it's really disruptive to the academic year, which is our main concern. So instead of turning buildings on 24/7, that's why we got this freeze protection sort of in here as an improvement, because before it was an improvement, it was a detriment. We started turning all buildings on in the wintertime, and now we have very specifically looked at an established path for turning buildings on a certain number of hours when it's under 20 degrees, and we have freeze stats on all of our coils. So we've gotten just much better at watching those freezing temperatures and how much energy we use. Back here, I really have no idea what this slight gain could have been. It was before there was an energy management department, so that data is harder to say.
And then in terms of the solution, one of the things that you might have heard about library makerspaces is that we provide, that they're aiming to provide technology such as, say, the Raspberry Pi, for example, which could be used by students and faculty to develop sensors, which could be used for that image, the steam or whatever. And I'd be interested in if that would be the right product. That would be good to have as a joint or community resource, commons, or if there's some way that would be helpful for a multidisciplinary team.
Yeah, I'm not,
But that is just.
okay.
Okay, we have time for one more question, and then I'm sure Caleb will be available afterwards to discuss more questions. Yes? Okay.
Caleb, I recently did a study on how old buildings were actually in the arts and sciences and what their dynamic looked like. So the average science building right now, arts and sciences, is 45 years old. And the question is, in getting to 117, is it feasible, given the infrastructure we currently have, to be able to achieve that?
Yes. We absolutely believe it's possible, and it's not just a fabricated number. We've put some data together, so we're actually using linear regression to sort of see where we think we can get if we're able to completely remove the weather dependency of campus. There's a lot of waste still going on this campus. I don't think anybody's going to argue that point. So I believe we can achieve 117 with existing equipment. In fact, when I was at the City of Houston in the Department of Sustainability there, we brought NASA in to look at exactly what you're talking about, building age and efficiency. And they found that it's really not correlated. Buildings tend to be cyclical in their efficiency because equipment goes out of spec and then it gets retuned right back into that spec. And you can bring it very close to a new building through retrofits.
Very cool. Thank you very much.
Thank you.